Yo ho,
yo ho, pirates, like for me.
It be talk like a pirate's day. I got my
Yar.
trusty duck. Funky. He's a funky duck.
Would that be appropriate for pirates' ducks, ain't it?
To be funky? Well, they smell funky, that's for sure.
Indeed.
Indeed. All right. Welcome, Precalculus, to a wonderful day of learning about functions. And we are now going to talk about something that you've learned before, but from the new perspective of functions. So we have here, Mrs. Contreras. What do we have here?
You sound like Bane. we be having a line that's be having a slope. The slope
A line that's be having a slope.
And the slope be negative. And it be a rational number.
Oh my gosh, we have lots of past knowledge coming to light. All right, but this be a function. This be a function because when you plug something in, something become out. What happened when you plug in 0?
You'll be getting 2.
Oh yes, because anything times 0 is 2.
The zero product property.
Oh, yes. What be another useful number to plug in here?
I think any number that will fit on our graph.
Yes, that is true, but look more closely at this number here.
I think we should plug in 4.
Agreed. -3 plus 2, that's -1. Let's start graphing these things. 0, 2, 4, -1. Now,
we should plug in -4.
Well, before you plug in -4, which is a great idea, do not disagree. How many points do you need to construct a line?
You only be needing 2 points.
And we have B 2 points. I put B's in weird spots. That's not what Paris necessarily. I'm going to construct this line. Why it's dotted, I don't know.
You don't want to be using the draw shapes and make a straight line in commie tools.
Let's take advantage of the commie tools.
Where be the
It'd be below the drawing shapes.
Insert
line.
And I'm going to take advantage of the fact that you said -4 is good. -4 going to be all right. Oh, look at that. It even gives us angles. All right, there we are. There we have a line. We've constructed our line with only 2 points. And this is a function, so we can get more points. And you said -4 gave us something, but instead of plugging it in, let's take advantage of the whole reason for a graph. To be able to see our values. So -4 gives us, what is that, 5?
I think it'd be 5.
And can we verify? 3 plus 2? Yes, 5. Right? Let's get a few more. Let's do 8. 8 is good.
8 is good because if you multiply by 3/4, you still get an integer.
Integer.
what is it though?
2 times 3 is
-6
plus
2 is -4.
Right, so, and then let's just fill out this chart.
Positive 8. I think the previous one.
Oh, this would be -4. And then what would -8 give us?
-8 would give us.
Or who does it give us 8?
6 plus 2.
8. All right. Let's not even fill this last one out. I'm getting tired of this. We have 2 and that's enough. All right. We are graphing linear functions. You said some very important stuff at the beginning though. Slope. What is the slope of this line?
The slope be -3/4.
-3/4. Interesting. Let's interpret this slope. -3/4.
Negative means that our function is decreasing.
From left to right.
From left to right, which we read left to right in the United States if we're reading English and other Romance languages.
Ah, yes, the Romance languages. This is the 1700s anyways. This video was made 300 years ago. All right, so it is negative. We go from left to right. And then we go down 3 and over 4.
It looks like you'd be making a triangle.
A right triangle.
I wonder if that will be important later.
Probably. All right. We have the slope here. Negative 3, 4. This is how we can interpret the slope. Rise over run. Let's look more closely at this function.
Can we also say that it's change in y over change in x?
Yes, and let's get fancy. Let's use delta
Delta.
y over delta x. All right.
Those are Greek letters.
Greek letters that mean change. That's an arrow. All right, let's look at this function though. And we have altered this document. R, x marked the spot. So we don't actually need this. We forgot to delete this. What is the domain of this function?
All real numbers.
All of them. You can plug in any number. That's what these arrows indicate. What be the range?
Also all real numbers.
I said no matter what number you give me on the y-axis, there is a number that takes you there. All the real numbers. You could also write these in interval notation. Negative infinity, positive infinity.
Some students have really been complaining about the way that you be writing your infinities.
No one of my students have. R. R be the real numbers. All right. Is this relation a function?
Yar.
20 million times now. Yar to be a function, yes. Because when you plug in one thing, only one thing comes out. You are guaranteed Coca-Cola if that is what you desire. You're guaranteed.
We don't know about Coca-Cola yet because
You're guaranteed.
it be the 1700s.
Mud, if that be what you require. All right. Is this function 1-to-1?
Yar.
Yar it be. Is yar yes in part?
Yar.
Yar. Yes it be. All right, so it is a it is a 1-to-1. It passes the horizontal line test, and our function yes be x coordinates versus y coordinates. So the vertical line test and the horizontal line test are valid here. Yes. All right. How can we identify the x-intercept?
The x-intercept is wherever the line crosses the x-axis or
What
the
is the y
horizontal
value?
axis.
That's the horizontal. What is the y value at the x-axis?
That is 0.
That is 0. So what we can do is set our equation. Set the y in our equation equal to 0 and solve. Subtract 2. Multiply by the reciprocal. 3, negative 3. That is not the reciprocal.
That should not be the reciprocal.
Negative 4/3 times negative 4/3.
8/3.
X equals positive 8/3. That be our x-intercept. And it looks like that is the case. 1, 2, 3, 4, 5, 6, 7, 8. Wonderful.
Should we write our x-intercept as a coordinate point?
I think we should. And here's why. When I say what is the x-intercept, I am asking for a coordinate pair. So let's write it as such. What be the y-intercept? Sorry, the y value of the x-intercept?
0.
0. All right, and the y-intercept, that is when the x is 0. So let's do the exact same process, but with x. Let's plug in 0 in for x. This actually be much easier. Negative.
We did already. It's in our table.
Oh, yeah, let me circle that in a new color. X marks the spot.
For the y value.
0, 2, and there it is. We've already even graphed it. There it is. Linear equations. Things to consider. What is the slope? Its numerator is the amount you rise, and its denominator is the amount you run. Run from the captain who is mad at you.
Or sail, as you are sailing in the
Rise
seas.
versus sail. Other things we care about. Lines are functions, and not only that, they are 1-to-1 functions.
Must
And
be
we
wonderful.
can find their x-intercepts and their y-intercepts by plugging in 0 into the respective coordinate within the coordinate pair, x or y. This is geometry. Proceeding. Now we've just talked about slope. Let's get a lot of those ideas down. Here's a line.
That's
How
be
could-
having a positive slope.
That be having a positive slope. So, slope can be positive or negative. Right, fact.
But between positive and negative, there's also a number. It's be 0. So what be a line that has a slope of 0?
Oh, a slope can be positive or negative. This one is positive. A slope that is horizontal has a slope of 0. This line right here. Let's call it line M. Gosh, that's a bad letter to choose. Let's call it line L.
H for
We'll call
horizontal.
this one H.
Okay.
Oh, actually,
That's
you're using
different.
better. You're using better. We'll call this one L for line and this one H for horizontal line. All right. The slope, which we use the letter M to describe, this is common knowledge in 1700, is, in this case, for the slope of, let me use a subscript, H, that is 0. Right? But what is the slope of our line L?
It'd be the
know-
rise over the run, or the
we know it
change
should
in
be
y
positive.
over change in x.
To be the rise over the run. But here's the beautiful thing about lines. It do not matter which 2 points you pick because slope is well defined. No matter what 2 points, if you simplify your rise, delta y over run delta x, it will always be the same number. We leave that as an exercise to the viewer, the scallywag watching this. Why
It may
would-
be related to similar triangle
Fact. So this is
This
delta
be
y over delta x.
geometry.
And it's be well defined. Write about that in your journal. What would a pirate call a journal? A journal. Wonderful. Some other things about slope you've already mentioned. Positive, that is moving up from left to right. Negative, that's me moving down from left to right. All right. What else can we talk about when it comes to slope? It's a very vast subject.
If you have something that is well defined, that makes me wonder, you could have something that is undefined. What be happening to the slope of a vertical line?
Yes, because what is the rise over the run? The rise is delta y. But the run is
0.
0. Right, what would be the slope? Something over 0.
We cannot say that.
Undefined. Right, the slope of our line U. Notice we use lowercase letters to describe lines, by the way. That's be undefined. Be careful, for an undefined slope can lead you astray. One last thing I'd like to add for those who love trigonometry is that if I take a triangle, and I'll add my triangle right here as well, delta y over delta x, and I'll add it back down here too, delta y over delta x. If you happen to have the angle, that is a theta, once again Greek, if you happen to have a theta, you can describe the slope using the tangent function. Because tangent is opposite over adjacent, which is delta y over delta x. So, slope be the tangent.
That be revolutionary.
This is something that is often made to walk the plank, one could say. It's just often forgotten about. It is often pushed to the side. but tangent is slope. Let us proceed. When given slope and given a point, you can describe a line. Mrs. Contreras, do you know all of the forms? If you don't, I will make you walk the
think
plank.
I could.
Like
There be standard form that
standard form.
many people deny use.
Today, I do believe it is a good form for reasons that will be revealed when we learn about vectors. Very useful to the pirates.
Vectors.
But standard form be ax plus by equals c.
Where A, B, and C be constants.
Yes, constants. Right. What other forms do we have?
There be the slope-intercept form. And that was what we started with.
Intercept.
Y equals mx plus b.
And I make the person that used this formula walk the plank, because this formula is awful. You are required to know the intercept, the y-intercept. I do not care about a y-intercept. This formula is awful. Do you know which formula is far superior?
Yes, I be having a favorite, and we save the best for last.
Always save the best for last. What be it?
It be the point slope form, because all you need is a single point and the slope from that point, and then ye be having a line. It doesn't matter what point ye be having.
Yeah. B? I don't want to give you B. I want to give you an arbitrary point, x comma y. X1.
An arbitrary
Right.
point.
Be giving arbitrary point. What be this point slope form?
Y minus y1 equals m times x minus x1, which is...
And I'll do you one
real-
better. I'll move that y1 to the other side. How does this make
But if you be doing that, then you lose the connection between the slope formula and the point slope form.
You are correct. Let's derive this formula real quick. Why does it even work? What is the slope?
The slope m be y minus y1 over
Delta
x
y.
over x minus x1. And then when you be multiplying by the denominator on both sides, you be having y minus y1 equals m times x minus x1. Equal signs work both ways, it doesn't matter. And then you can be moving that minus y1 to the others.
Excellent. And we won't do that because you've made a very compelling argument to keep it in this form. This form makes sense. Unlike that scallywag that be mopping the plank, mopping
The poop deck.
The poop deck. He makes no money. No sense. All right. So we have these three forms, and this one is the best because if I give you a point, you're done. If I give you the point 39,77, I have not be given you the y-intercept. Don't go and find it. Use what has been given to you.
That be unnecessary.
And if you so choose to go to slope-intercept, just go to it from this form. Let's do this once. Write an equation that represents a line with a slope of 2/3 that passes through the point -5/8. Normally in class, I would have one student go up and do this in point slope form, and one student go up and do it in slope-intercept form, and then watch the second person struggle while the first person sits back down with time to spare. But here we will just do it in point slope form, and then move it to the slope-intercept form. So what be it in point slope form?
It'd be y minus 8 equals 2/3 times the quantity x plus 5.
+5? But that's a
Minus
negative.
negative is plus.
You're right. Minus a negative is a plus. This is going to be really fun to watch at 2 times speed, I'm sure. How can we move this to the far inferior form, the Slope-Intercept Form?
We needed to distribute that 2/3 everything inside its parentheses.
Distribution, not FOIL, because FOIL makes no sense here.
Doesn't make
Distribution.
sense.
So we have y minus 8 is equal to 2/3 x plus 10/3.
And then we needed to move the 8 over and then add some fractions.
10/3 plus
24/3.
which is 24/3. 24 plus 10, 34. And that is in its co-prime state. There are no common factors of 34 and 3. It is not being simplified. 2/3 x plus 34/3. That number is disgusting. Why would you want it when you could have -5/8? Integers, whole numbers. 34/3 for fools.
And scalawags.
And we're not even going to even talk about standard form. I like standard form, but we're not going to worry about that right now. I implore you, listener, to think about the relationship between A and B and M. What's M, you ask? The slope. Have you not been listening? What's be the relationship? But that is a viewer for the listener. We'll put a question right here. All right, let's proceed. Ooh, we know the answers to these. We have already talked about them. The slope of parallel lines, 0. The slope of perpendicular lines, I was about to say the answer. Undefined.
Slope of parallel lines be 2 lines that be having the same slope.
Oh, I am very disoriented from my eye patch because I don't actually need it. This has nothing to do with vertical and horizontal lines. This is not that at all.
It'd be okay, Mr. Kirk. So
Sorry
Captain Kirk.
Captain Kirk. Funky the Duck be falling over.
And be judging you for not reading.
Slope of parallel lines. What be the slope of parallel lines?
They be equal. Because the rise over the run be the same.
Yes, and if you want to get real fancy, let's extend this line. Let's extend these lines. And we can talk about alternate interior angles and similar angles and similar triangles, but we won't do that here. The slope of parallel lines are equal. How about the slope of perpendicular lines?
Perpendicular lines, they not be having equal slopes, they be having reciprocal and negative.
And negative. I have slope L, and I have slope, and a line L and line M. Once again, M is a bad letter to choose. If I have line, it's an arrow. L and Z. If line Z have slope, if line Z have slope, if line Z have slope something, A over B, where A and B are any number, then the slope of line L be the negative reciprocal.
As long as B not be 0.
As long as B not be 0. But what do we do when it is 0?
Then we have a slope that is undefined. But the slope of a perpendicular line to that, I believe it could be horizontal.
If MZ be 0, then ML be undefined. When I messed up earlier, I was just seeing into the future. Let's proceed. Here are two examples of those aforementioned horizontal and vertical lines. Y equals 3. What'd be that?
That'd be a horizontal line.
Ah, yes, well, because give me a coordinate that has 3 as its y coordinate. Give me a coordinate pair where 3 be its y coordinate.
5,000, 3.
I do not have that on my graph, but I will do 5, 3. Give me another point.
Negative
Y.
7, 3.
Give me one more.
0, 3.
Y equals 3 is the line where the y coordinate of all points be 3. Thus, it be a line parallel to the x-axis. This confuses people. They think y be vertical. Not here. Y be constant, 3. X be variable. Similar over here. X be negative 5. Give me 3 points. Or better yet, give me 2 points, because 2 points define a line. Give me 2 points where x be negative 5.
Negative 5, 10. Negative 5, negative 10.
Oh, you're mean when it comes to graphing lines. So far apart.
You be having the shapes tool. I don't know what you're complaining about.
I once again forgot about it. I'm not going to go back and at it this time now. All right. That be our line. Let's inspect these lines. What properties do they have? Are they functions? We said earlier that lines are functions. Are these lines functions? What be the domain of y equals 3?
Let's be all the real numbers.
What be the range?
Only 3.
And I will write it with a curly bracket 3, curly bracket.
Singleton set.
Singleton set. Is the relation a function? Or we be back recording this lesson. We left off talking about linear functions of which have slope 0 and slope undefined. X equals negative 5, a vertical line. Mr. Contreras, does this line here, x equals negative 5, have, what is its domain?
Domain be a singleton set.
Oh, the
Need only be negative 5.
Negative 5. What be the range?
The range be all real numbers.
Is this relation a function?
Nay, it nay be a function. Nay, nar.
Nay.
Nay.
Nar. Is this relation 1-to-1?
Aye.
Well, we talked last time about how 1-to-1 is a quantifier for a function.
But we have relation is 1-to-1.
Oh. Can you elaborate?
Well, I think we can have relations that be not functions. And those relations can be 1-to-1.
Interesting. So if you're telling me the range value of 7 only has one domain value associated with it?
Aye, it be negative 5.
Let's be negative 5.
Ask me another.
Ask me another. How about negative 9?
It be negative 5.
Oh, it'd be negative 5. This is, in fact, a 1-to-1 relation. Yay. Yar.
Aye.
That's not how you spell I, but it is how I am spelled. What be the X-Intercept?
The X-Intercept. There's only one thing it could be. X equals negative 5 and Y equals 0.
R-I-A-E-I-O-U.
Aye.
A. Y-intercept?
There be no Y-intercept.
Not applicable. Okay, let's proceed. All right. New topic of review that we want in our pocket. Midpoint formula. How do I find the midpoint between 2 points?
We should probably look at the line.
Let's look at the graph. 5, 2. That's a terrible, that is not
Not a good idea.
accurate. 5, 2.
5.
5, 6.
Need to go up.
We need to go up, yes. How can we find the midpoint of this?
Well, that's line segment, right? Because it has an endpoint on the top and the bottom. And this line be straight. Well, up and down with a slope that's undefined. We can just find the middle.
Find the middle.
This line.
Right there.
What is
Lead us point.
between 2 and 6?
4.
Far.
Now, can we generalize the midpoint formula?
We should probably look at the difference between our different coordinates.
Well, we don't want to find the difference between, because the midpoint, that's the middle point. When I think of a data set, I think of the middle of the data set. What is the middle of the data set?
I think it'd be something that you might mean.
No. There's 3 types of middles, right? There's the mode, the median, and the mean. Now, what we want to do here is we want to find the midpoint. We want to find, in other words, the average point. How do you find the average of 2 values? What is the average x-coordinate? How do you find the average of 2 things?
You should probably add them together.
Average out 2. So for the average, x-coordinate, we take 5. And we take 5. We add them.
There's 2 5s.
Then we divide by 2. All right,
think
let me
that'd be-
rewind a little bit. Here, we take 5, we add 5, and we divide by 2. We find the average x-coordinate. We take the first x-coordinate, we take the second x-coordinate, and we find the average. How about the y-coordinate? What will
I
that be
think-
here?
We have 2 and we have 6.
That is 8 when summed, divided by 2. That is, in fact, what we have received. 5 plus 5 is 10, divided by 2 is 5. 2 plus 6 is 8, divided by 2, that is 4. Our midpoint is, as inspected by graphical methods, 5, 4. But with our algebraic method, we have found the average. The midpoint formula looks complicated, but all it is the average of the individual coordinates in the coordinate pair. Let's do that over here without a graph. Sometimes a graph can be confusing. What is the average x-coordinate?
-2 and
Negative
4
2 plus 4 divided by 2.
divided by 2.
-1 plus 7 divided by 2. This ends up being 2 divided by 2. 1. 6 divided by 2.
3.
And let's just verify it with a picture. -2,
Picture.
comma -1. Roughly there. This is a sketch, not a graph, a sketch. 4, 7 is up here. And you know what? 1, 3 definitely feels like the midpoint. The average point is how we find the midpoint of two points.
Are those 3 points collinear?
If I had drawn them nicely, yes, they are collinear. To get some vocabulary out there. That was a stretch.
That was pretty bad.
So we want to use the midpoint formula, and we want to use the perpendicular properties of lines to answer this. This question here is actually quite difficult. For each problem above, and you know what? Let's just do it with the second one. We want to find an additional point that is equidistant from each pair of points. Another point in the middle of 2 points? How dare I?
Well, I think the thinking about in the middle might be a wee bit confusing. Because it doesn't necessarily have to be directly in the middle. Because if I have
a point that is equidistant, I'm going to call this point A and this point B.
If we have some point, if we have A and B, and we have this C here, M here, and then we want to see what could be in between, but it's still equidistant. Perhaps we could perhaps construct a line.
One might call it the perpendicular bisector.
Bisector.
It's because you learned in geometry that every point on the perpendicular bisector is equidistant from the endpoints of the segment. This is a quick triangle proof. These are congruent, right? The reflexive property, the definition of midpoint, and right angles, side angle, side. So we need to find another point. We need this line.
But we know how to find, we do know how to find the slope of that line, and we have a point for that line.
Yeah, we already have a point, M, which we've established as 1, 3. What is the slope of this line?
We need the change in y over the change in x.
We do.
Which I think is 7 minus -1 over 4 minus -2.
Let's call this line right here L, and call this line Q. The slope of L is derived from the points that we have been given. 7 minus -1 divided by 4 minus -2. 8 over 6. 4 over 3. I want the slope of line Q. What is the slope of line Q?
The negative reciprocal.
Reciprocate. Negate. That rhymed. It was unintentional. Reciprocate and negate. -3/4. We have a slope. We have a point. Should we find the slope-intercept form?
Why?
Funky Duck says no. Didn't see that one coming. Point slope form is the superior form. Y minus y1 times the slope distributed amongst x and the opposite of x1 minus x1. There it is, we're done. We have finished. That is the equation.
But we need to find a point.
Well, once again, I have yet to read the prompt correctly. Heed my mistake. We need another point. How will we find this point?
We just pick a number.
It's a function. Plug in a value and get out a value. Let's plug in
5.
I see why you picked that. 5 minus 1.
4.
4 times -3/4.
-3.
Add 3 to both sides and we are left with 0. 5, 0 is this point right here. We have succeeded. With teamwork, not only did we get the line of the equation of the line, but with your help, I have also found a point on the line, not the midpoint, that is equidistant from A and B. It's a difficult problem with many layers, like an onion or a cake.
Or an ogre.
Or an ogre. We're almost done here, students. Scalawags. Shipmates. But we want to get one last geometric concept into your pocket from last year. Maybe you're an expert. Maybe this refresher was needed. The distance formula. The distance between points. Now, there is a formula, but I want to know why that formula is the formula. Just like we learned why the midpoint formula is the formula. It's the average point. We take the average, the distance formula. To do this, to derive the formula, let's give ourselves some scenarios. Negative 3, 8, 7, 8. Negative 3, 8, 7, 8. What's the distance between these 2 points? Is a formula even needed?
Nay.
Wonky Dunk says nay too. We want the distance. Let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is there a better way I could have done that?
Yes.
Mm.
So much better.
So much better. We could have used...
The difference of 7 and negative 3.
Yes, the one-dimensional distance formula. When on a number line, take your second value and subtract your first value. All right, and if both are negative, just take the absolute value. 8 minus negative 3. The absolute value of that is 10.
I think we need 7 minus negative 3. I think 8 is just the y value that
but
never changes.
Did you know that 8 minus negative 3 is also 10?
I think that is a new branch of mathematics that I am thus far unfamiliar with.
I blame the eye patch.
It's reasonable.
Reasonable. All right, so we can use absolute value to find the distance between points that have the same y value or the same x value. But what if they are skewed? Negative 5, 2, 4, negative 5. I cannot just count my way across because the distance between each of these is much larger than 1. How can I get to the distance between these 2 points?
I would like to draw a triangle.
Triangles. All right. Triangles do seem to be the reason for lots of math. If you don't like math, then one might hate a triangle. But we all love math, and if you don't love math, walk the plank. We have a distance here of 1, 2, 3.
It'd be okay to not totally love math, Mr. Captain Card. Think of the children.
I will. So the distance between these 2 points we just established is the absolute value of the first point minus the second point. So we have 2 minus negative 5, which is 7. Here we have 4. Oh no, sorry, 1, 2, 3. Yes, 4.
I got that right?
Yes, 4 minus negative 5, which is 9. How does one find the distance between these 2 points?
I think perhaps we would need to use the Pythagorean Theorem.
Pythagoras? Pirates don't like Pythagoras.
Why not?
There's an old tale that I will let you tell.
Legend has it that the Pythagoreans, number 1, they were a cult. Cults are bad, so avoid cults if you can.
If you can.
But the Pythagoreans, they thought that every number had to be an integer, and it could be part of a Pythagorean triple. That's what they was thinking.
So they said that 7 and 9 could be part of a triple of integers?
Integers, potentially. However, one day, a person in the Pythagorean group was...
For the sake of names, what was his name? Make it up now.
We could call him Bootstrap Bill.
Bootstrap Bill.
The most Greek name ever. But they were on a ship and they were doing some math, as one does.
On ships, yes.
Hmm. And Bootstrap Bill conjectured what would happen if we had two legs of our triangle were one. What would the hypotenuse be?
Well,
And he
one
thought that
square-
there was some number that would break their idea that all the numbers had to be integers and Pythagorean triples. So they were so upset. They took Bootstrap Bill. They tied his bootstraps to something very heavy, probably like a rock or something, and then they threw him off the boat. And that was the end of Bootstrap Bill. Incidentally, we know the Pythagoreans were wrong, which is yet more evidence to avoid cults if you can.
Yes. So you're telling me that this number might not be a whole number?
It may not be an integer.
Yet another reason not to just count like a fool.
Indeed.
All right, we're here. We had the Pythagorean Theorem. I have done on the side here a little discussion on root 2 being not an integer. Thus, Bootstrap Bill being thrown off the plank. 7 squared is 49. 9 squared, that's 81. Their sum is 130. And I believe that this number's square root is in between 11 and 12.
Because 11 squared, that is 121. And 12 squared is 144.
44.
130 is between 121 and 144. Good estimation, Miss Captain Kirk.
Yes. I am going to pause the video. How's your voice?
Ahoy!
Ahoy there, matey. We are back once again.
The third time. Mr. Kirk, you're not sharing your screen.
Oh, not. Oh, this is okay. This will be funny.
Or just real
No, I'm sharing my screen. Please tell me I'm sharing my screen.
Hi.
No, I. All right, where did we leave off? We were using the Pythagorean theorem. Not necessarily invented by Pythagoras, but credit has been given to them. Fun fact, this theorem was invented all over the world around the same time, if not hundreds of years before Pythagoras was given its namesake.
Wild.
Where were we though? Ah, yes, let's generalize this formula. Right? And I'll use this space right here that hasn't been used. But let's say I'm given some arbitrary point, x1, y1, and another arbitrary point, x2, y2. How do we find this distance?
We need to take the difference between the two x values. Let's say x2 minus x1.
Yes.
Because that's the
absolute
horizontal
value of x2.
horizontal leg of that triangle.
And as we stated before, if we take the absolute value of one value and the other value, the difference, the absolute value, that we get the positive length, we have one leg of our triangle, of our right triangle.
We have the bottom leg of our triangle.
Oh, I think I messed up. Yeah.
You just change those to y's, it's okay.
Yeah.
Or you can just erase it all.
I have strong opinions about pencils versus pens. Pencils, I believe, are better.
There is an eraser tool.
There is an eraser tool. Well, yes, in real life, you might be doing this with a pencil. You have an eraser. Use it.
Unless you're on an AP exam and then you could just cross it out.
Yes, that is more efficient. We digress. It sounds like you're a pen fan.
I like doing math in pen when I'm doing it for myself. But when I'm doing math for other people, I like to use pencil.
Ah, you are a caring, kind pirate. What is this length?
That is what we talked about before, that is the difference between the x values, but the absolute value of it, because a distance can be negative.
We want this distance right here. So how do we get to this distance?
We need to square both of those magnitudes, or not, those absolute values.
And let me actually write the absolute value. And I have a kind of a philosophical question in a second, but do we even need these absolute values? We're going to square it,
I think we do not.
right? And then we're going to square this one. And that becomes our distance squared, Pythagoras. But we do not need those absolute values. Can you tell me why?
Because whenever we square values that are real, and these are real values indeed, then we always have a non-negative value.
Yes. Let's stroll down and derive the distance formula. I think we're one
Square root.
Yes. We don't need to worry about any negatives under the square root because, as we have previously said, these are positive values.
Or at least non-negative.
At least non-negative, thank you. They make to be zero. As in our first
Like that
example,
horizontal line that we had.
y2 minus y1 here is zero. All right. So we have d, the distance.
It's a positive value, is it not?
It is. Right, if I were to square root an equation, normally I'd put a plus or minus, but here I do not need to. We have x2 minus x1 squared plus y2 minus y1 squared. And there you have it. The distance formula is really just the Pythagorean theorem in disguise. Another reason why Pythagoras is evil.
Pythagoras might have been an alright dude. We don't know.
We
Might
don't.
have not even, yeah, I'm losing my words. He might have not even been a person. Might have just been that cult group. Records are gray.
I'm back. I don't know who that was that you just heard from, but they were probably intelligent beyond comprehension. I believe we have it there. A little geometry review. We'll be using these topics constantly in this subject, in this course, the course of precalculus, the course of calculus and beyond. Do you have any final words, matey?
Matey. Oh, we can use matey. I think that'd be a good way to wrap up Talk Like a Pirate Day.
It is Talk Like a Pirate's Day today. You may be watching this on not Talk Like a Pirate Day, but it never hurts to let your inner pirate out, even on the days we do not celebrate. Don't forget to like and subscribe. Smash that subscribe button, and we will see you on the horizon.
Alright, so let's like kind of like
Like put like we're like doing that.
yeah, wait. It doesn't work though because it's the full screen.